Pre-stressed concrete structures questions and answers, pretensioning systems. Previous. Next. This set of pre-stressed concrete structures multiple choice questions and answers, MCQs, focuses on pretensioning systems. 1. The tendons in the pretensioning system are tensioned between underscore 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 underscore. A. Rigid anchorages. B. Hydraulic jacks. C. Concrete beds. D. Variable beams. U. Answer. Answer A. Explanation. In the pre-stressing system, the tendons are first tensioned between rigid anchorage blocks cast on the ground, or a column, or a unit mold-type pretensioning bed, prior to the casting of concrete in the molds. 2. When the concrete attains sufficient strength, which elements are released? A. Jacks. B. Casting bed. C. Tendons. D. Beams. U. Answer. Answer A. Explanation. High early strength concrete is often used in factory to facilitate early stripping the reuse of molds, and when the concrete attains sufficient strength, the jacking pressure is released and the edge of tendon at its either side is formed to an abutment, and its other edge is to be pulled with the application of jack. 3. Which is one of the systems used for pretensioning? A. Magnol-Bolton system. B. Freycinet system. C. Gifford-Udall system. D. Hoyer's long line method. U. Answer. Answer D. Explanation. Hoyer's long line method is the system used in pretensioning, and the other systems like Freycinet, Gifford-Udall, and Magnol-Bolton are post-tensioning systems, and large numbers of beams are produced in an individual alignment. 4. Hoyer's system of pre-tensioning is generally adopted for underscore 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 underscore. A. Small scale members. B. Large scale members. C. Middle span members. D. End members. U. Answer. Answer B. Explanation. Hoyer's system is generally recommended when the production of pretensioned members is required on a large scale as the principle which are used to precast the beams. The post-tensioning system was considered to pretensioning system when used for large spans. Due to this reason the pre-tensioning system was replaced by post-tensioning system. 5. The transfer of pre-stress of concrete is achieved by underscore 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 underscore. A. Plates. B. Rings. C. Steel bars. D. Jacks. U. Answer. Answer D. Explanation. The transfer of pre-stress to concrete is usually achieved by large hydraulic or screw jacks, by which all the wires are simultaneously released after the concrete attains the required compressive strength. Generally strands of up to 18 mm diameter and high tensile wires of up to 7 mm diameter anchor themselves satisfactorily with the help of surface bond and the interlocking of the surrounding matrix in the micro indentations on the wires. Advertisement. Join Sand Foundry at LinkedIn. 6. The bond of pre-stressing wires in Hoyer's system can be formed by underscore 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 underscore. A. Helical crimping. B. Tangential crimping. C. Circular crimping. D. Diode crimping. U. Answer. Answer A. Explanation. Bond of pre-stressing wires may be considerably improved by forming surface indentations, and by helical crimping of wires in Hoyer's system. Strands have considerable better bond characteristics than plain wires of equal cross-sectional area. Supplementary anchoring devices are required when single wires of larger diameter are used in the pretensioned units. 7. The Hoyer's method of pre-stressing is done by underscore 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 underscore. A. Pulling out of wires. B. Pushing wires. C. Heating of wires. D. Stressing of wires. U. Answer. Answer A. Explanation. Hoyer's system of pre-stressing involves pulling out of wires between two bulkheads, which are separated at large distances in order to produce a larger number of beams in an individual alignment. The concrete is to be poured by providing appropriate shuttering between the beams, and then the wires are united after hardening of concrete and cut off. 8. Hoyer's system of pretensioning can be done for beams. A. 1. B. More than 2. C. Less than 2. D. 2. U. Answer. Answer B. Explanation. United beams more than 2 are hardened in Hoyer's method of pretensioning in case of large distances between each beam. The most commonly used devices are the Weinberg clip developed in France and the Dorland clip developed in the United States. These clips are clamped onto the tensioned wires close on the end diaphragms of the units before concreting operations. 9. The Hoyer's system of pre-stressing proves to be economical for A. Pre-tensioning system. B. Post-tensioning system. C. Beam casting. D. Bed casting. U. Answer. 10. In Hoyer's system, the projection of plugs left in concrete exceeds beyond A. Middle of member. B. End of member. C. First of member. D. Transfer part of member. U. Answer. Answer B. Explanation. One of the disadvantages of Hoyer's system is the projection of plugs which are left in concrete exceeds beyond the end of the member. Application of heavy jacks, which are uneconomical. Projection of plugs which are left in concrete exceeds beyond the ends of the member. Additional reinforcement is required to prevent failure of shear. Sand Foundry Global Education and Learning Series, Pre-stressed concrete structures. Pre-stressed concrete structures questions and answers, post-tensioning systems. Previous. Next. This set of pre-stressed concrete structures multiple choice questions and answers, MCQs, focuses on post-tensioning systems. 1. In post-tensioning, the concrete units are cast by A. Ducts. B. Jacks. C. Anchorages. D. Wedges. U. Answer. Answer A. Explanation. In post-tensioning, the concrete units are first cast by incorporating ducts or grooves to house the tendons, and when the concrete attains sufficient strength, the high-tensile wires are tensioned by means of jack bearing on the end face of the member and anchored by wedges or nuts. 2. After the tensioning operation, the space between the tendons and the ducts are A. Layered. B. Grouted. C. Cemented. D. Drilled. U. Answer. Answer B. Explanation. The focus are transmitted to the concrete by means of the end anchorages, and when the cable is curved through the radial pressure between the cable and the ducts, and the space between the tendons and the duct is generally grouted after the tensioning operation. 3. The Freycinet system of post-tensioning anchorages was developed in A. 1934. B. 1935. C. 1939. D. 1936. U. Answer. Answer C. Explanation. Freycinet system of post-tensioning anchorages, which was developed in 1939, gave impetus to the various new systems devised over the years, and at present, according to Abels, there are over 64 patent post-prominent systems used worldwide. 4. The Freycinet system of pre-stressing involves the arrangement of wires of number A. 10. B. 14. C. 12. D. 8. U. Answer. Answer C. Explanation. Freycinet system of pre-stressing involves the arrangement of high-tensile steel wires of about 12 in number with diameter of 5 mm to 8 mm forming a group into a cable. Cylinder is provided as an anchorage, and it has a conical hole, at its center provided with heavy hoop reinforcement. These cylinders are provided as an anchorage, and it has a conical hole at its center provided with heavy hoop reinforcement. 5. In Freycinet system, which element behaves as a guide? A. Spiral spring. B. Hollow spring. C. Trapezoidal spring. D. Cable spring. U answer. Answer A. Explanation. In Freycinet system of pre-stressing, spiral spring is provided inside the cable for sufficient clearance between the wires, and it even provides a cement grouted channel, and the spiral spring behaves as a guide in transferring the reaction to concrete. Advertisement. Join Sand Foundry at LinkedIn. 6. Which of the following is a disadvantage of Freycinet system? A. Stresses in the wires are not similar. B. Rapid attainment of stretching force. C. Safeguarding of wires is economical. D. Projection of plug left in concrete. U answer. Answer A. Explanation. The stresses in the wires are not similar, even though all the wires are been stretched together. Freycinet system involves the application of heavy jacks, which are economical. Force applied for stretching is about 250 knots to 500 knots, which is maximum, and is still inadequate. 7. In Gifford-Udall system, the number of methods for pre-stressing members is A. 1. B. 2. C. 3. D. 4. U answer. Answer C. Explanation. Gifford-Udall system gave 3 methods for pre-stressing members by small wedging grips, anchoring of wires by wedging, application of tendons of H.T type with a diameter of about 28 mm, and this method of pre-stressing involves the anchoring of wires by wedges, due to which the wires directly fit into the tapered recesses present over the bearing plate. 8. In Gifford-Udall system, which method involves pre-stressing by H.T type tendon? A. Method 1. B. Method 2. C. Method 3. D. Method 4. U answer. Answer C. Explanation. Gifford-Udall system consists of 3 methods, in that third method of pre-stressing involves the application of a tendon of H.T type with a diameter of about 28 mm, and it is quite stronger than 6 mm diameter wires. 9. In Lee-McCall system, the pre-stressing tendons are in the form of underscore 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 underscore. A. Steel bars. B. Tension bars. C. Compression bars. D. Rings. U answer. Answer A. Explanation. In Lee-McCall system, the pre-stressing tendons are in the form of high-tensile alloy steel bars, and the bar size ranges from 12 to 40 mm diameter, and after tensioning, the bars are anchored by special threaded nuts which bear against a distribution plate. 10. The drawback of Lee-McCall system is it cannot use underscore 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 underscore. A. Straight tendons. B. Elliptical tendons. C. Curved tendons. D. Trapezoidal tendons. U answer. Answer C. Explanation. In this system, the forces are transmitted by the bearing at the end blocks, while the system eliminates the loss of stress due to anchorage slip by screwing a nut and washer against end blocks, and the drawback of this system is that it cannot use curved tendons. 11. The method of tensioning Magnell-Bolton system involves underscore 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 underscore. A. Hydraulic jack and wires. B. Hydraulic jack and bars. C. Multi-strand hydraulic jack. D. Jack inserted at center of beam. U answer. Answer A. Explanation. The method of tensioning Magnell-Bolton system involves hydraulic jack tensioning 2 wires at a time. The arrangement of Magnell-Bolton system constitutes of a rectangular cable section provided with layers of wires of diameter about 5 mm to 8 mm, such that each layer is supplied with 4 wires, and the arrangement of wires in the geometric pattern is to be considered by supplying spacers/grills at uniform intervals throughout the length of the cable, and adequate resistance against friction for the wires in the of sandwich plates. 12. Which system of pre-stressing is widely used in India? A. Gifford-Udall. B. Lee-McCall. C. Magnell-Bolton. D. Freycinet. U answer. Answer D. Explanation. The Freycinet anchorage system is widely used in Europe, and India consists of a cylinder with a conical interior through which the high tensile wires pass, and against the walls of which the wires are wedged by a conical plug lined longitudinally with grooves to house the wires. Sand Foundry Global Education and Learning Series, Pre-Stressed Concrete Structures. Pre-stressed concrete structures questions and answers, tensioning devices. Previous. Next. This set of pre-stressed concrete structures multiple choice questions and answers, MCQs, focuses on tensioning devices. 1. In pre-tensioning system, type of pre-stressing tendon used is underscore 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 underscore. A. Bars. B. Wires. C. Strands. D. Cables. U answer. Answer C. Explanation. The strand tendons are used in both pre-tensioning and post-tensioning. They are made by winding 7 cold-drawn wires together on a stranding machine. The addition of strands in subsequent layers of wire forms strands of 19 or 37 wires. Large post-tensioning applications can cope with stressing requirements by use of these tendons. 2. The yield stress relieved in wires is about underscore 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 underscore. A. 620 MPa. B. 1300 MPa. C. 1250 MPa. D. 600 MPa. U answer. Answer B. Explanation. The wire tendons are mainly used in post-tensioning system for pre-stressed concrete. They are cold-drawn and stress is relieved with a yield stress of about 1300 MPa, and the diameter generally ranges from between 5 mm to 8 mm. 3. The use of bar tendons with threaded anchorages reduces the possibility of underscore 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 underscore. A. Push. B. Pull. C. Break. D. Bend. U answer. Answer B. Explanation. The bar-type tendons are used in certain post-tensioning systems. The bars are of high-strength alloy steel of yield strength about 620 MPa and diameter up to 40 mm, and the use of bar tendons with threaded anchorages reduces the possibility of pull-in at the anchorages and also anchorage cost. 4. The cables are formed by arrangement of wires or strands in underscore 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 underscore. A. Bundles. B. Rings. C. Ducts. D. Steel. U answer. Answer A. Explanation. The cables are formed by arrangement of wires or strands in bundles, and the performed duct in concrete member can be stressed and tensioned by appropriate post-tensioning method by using cables. Post-tensioning is invariably used for strengthening concrete dams, circular pre-stressing of large concrete tanks and biological shields of nuclear reactors. 5. How many types of splicing arrangement are widely used in post-tensioning systems? A. 4. B. 5. C. 3. D. 2. U answer. Answer A. Explanation. Screw connectors are normally employed to splice large diameter high tensile bars, which can be threaded at ends. The torpedo splice consists of triple wedges for securing the wires, and the entire unit is covered and protected by a sleeve. Clamp splices are equipped with bolts and nuts with a series of clamp plates to house the tendons between them for splicing of small diameter wires of 3 to 6 mm. Advertisement. Join Sand Foundry at LinkedIn. 6. The commonly used mechanical devices used in the following statement. A. Weight with lever transmission. B. Geared transmission without pulley blocks. C. Hydraulic jacks. D. Tendons. U answer. 7. The hydraulic jacks are the simplest and most widely used devices for providing prestress of underscore 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 underscore. A. High magnitudes. B. High discharges. C. High bending moment. D. High tension. U. Answer. Answer A. Explanation. Hydraulic jacks are the simplest and most widely used devices for providing prestress of high magnitudes, and various hydraulic devices are prepared by different scientists, from which the commonly used devices Freycinet, Magnell-Bolton, Gifford-Udall system, Bauer-Leonhardt, Lee-MC-Call system, Press-Con system, etc. 8. The applied force should be measured accurately in hydraulic devices while A. Tensioning the tendons. B. Tensioning the wires. C. Tensioning the cables. D. Tensioning the anchorages. U. Answer. Answer A. Explanation. The prestressing members with hydraulic devices, the applied force, should be measured accurately while tensioning the tendons, and this can be achieved by providing pressure gauges with the jacks. 9. The electrical devices are commonly used for tensioning of underscore 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 underscore. A. Bend wires and steel wires. B. Deformed bars and steel wires. C. Torsion and steel wires. D. Compression wires and steel wires. U. Answer. Answer A. Explanation. Electrical devices are used commonly for the tensioning of deformed bars and steel wires, and the method of pre-stressing involves the heating up of steel wires and anchoring them before filling the molds with concrete. 10. The basic chemical substance used for pre-stressing forces in concrete member is underscore 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 underscore. A. Aluminium. B. Sulfur. C. Shrinkage cement. D. Expanding cement. U. Answer. Answer D. Explanation. Chemical substances are also used for developing pre-stressing force in concrete members, and the basic chemical substance used is expansive cement. When expansive cement is used in construction, the tendons are subjected to tension while setting. Sand Foundry Global Education and Learning Series, Pre-stressed Concrete Structures. Pre-stressed concrete structures questions and answers, thermoelectric pre-stressing. Previous. Next. This set of pre-stressed concrete structures multiple choice questions and answers, MCQs, focuses on thermoelectric pre-stressing. 1. The method of pre-stressing by heated tendons, achieved by passing an electric current, is known as underscore 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 underscore. A. Chemical pre-stressing. B. Thermoelectric pre-stressing. C. Dynamic pre-stressing. D. Thermoblasting pre-stressing. U. Answer. Answer B. Explanation. In this method the tendons are heated through the high tensile wires, and by allowing electric current to flow through it, this process is referred as thermoelectric pre-stressing. In the erstwhile U.S.S.R., the electrothermal method has been widely used since 1958 for pretensioning bar reinforcements of precast units. 2. In thermoelectric pre-stressing, heating the bars is done to a temperature of underscore 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 underscore. A. 300 to 400 degrees. B. 500 to 600 degrees. C. 200 to 300 degrees. D. 150 to 450 degrees. U. Answer. Answer A. Explanation. The temperature in the bars is raised from 300 to 400 degrees for a time duration of 3 to 5 minutes. With this the bar elongates up to 0.4 to 0.5%. Empirical relations for the estimation of the current, voltage and power requirements of the transformer are reported by Graddock. 3. The period of cooling in thermoelectric pre-stressing is observed as underscore 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 underscore. A. 20 to 30 minutes. B. 12 to 15 minutes. C. 5 to 10 minutes. D. 15 to 20 minutes. U answer. Answer B. Explanation. After the process of cooling, the bars get shortened, but which can be known with a fixed arrangement at both the ends, and the period of cooling is observed as 12 to 15 minutes. A steel metal sheath of enlarged diameter and sufficient length is generally used to cover the splice. Screw-threaded connectors are not recommended for splicing heat-treated pre-stressing steels, which are highly susceptible for stress corrosion. 4. The thermoelectric pre-stressing. Initial stress in tendons ranges between A 500-600 N/mm2, B 200-300 N/mm2, C 100-150 N/mm2, D 600-800 N/mm2. U answer. Answer A. Explanation. Thermoelectric pre-stressing helps to cause on initial stress in tendons of magnitude from 500 to 600 N/mm2, and concrete is placed in molds only after the temperature of the wires falls below 90 degrees. 5. In which place thermoelectric pre-stressing found to be more economical? A. Canada, B. USSR, C. France, D. Switzerland. U answer. Answer B. Explanation. In the erstwhile USSR, the thermoelectric pre-stressing method has been widely used since 1958 for pre-tensioning bar reinforcements of precast units, and this method has been found to be more economical than conventional mechanical devices. Advertisement. Join Sand Foundry at LinkedIn. 6. The thermoelectric pre-stressing is also used in A. Pre-block units, B. Precast units, C. Pre-beam units, D. Pre-anchorage units. U answer. Answer B. Explanation. Thermoelectric pre-stressing is adopted in many foreign countries, as it is most economical when compared to the other conventional mechanical devices. It is also used in precast units. Precast are only used within ranges of exterior and interior walls compressed in concrete and stone, creating a solid, but maneuverable wall or face. Precast concrete production performed on ground level, which helps with safety throughout a project. 7. The tensioning of oval section ribbed wires with an ultimate tensile strength was adopted in A. Germany, B. France, C. Switzerland, D. Britain. U answer. Answer A. Explanation. Thermoelectric pre-stressing has also been adopted in Germany for the tensioning of oval section ribbed wires with an ultimate tensile strength of 1600 N/mm2. The wrapping wire of 1 mm diameter is generally used for splicing wires up to 6 mm diameter, and the length of splice may vary from 20 to 30 centimeters, and the splice formed in this manner has a strength almost equal to that of the normal wire, and this type of splice is generally used for the wires of circular concrete tanks and anchorage loops. 8. The estimation of the current, voltage and power requirements of the transformer are 4 A. Theoretical equations, B. Empirical relations, C. Global relations, D. Quadratic equations. U answer. Answer B. Explanation. A temperature of about 4600 C was necessary to induce an initial stress of 55% of the ultimate tensile strength, the heating time being 40 to 90s at 30 V and 300-1100 A, and empirical relations for the estimation of the current, voltage and power requirements of the transformer are reported by Graddick. 9. In thermoelectric pre-stressing, the elongation is observed in case of A. Bar after cooling, B. Bar after heating, C. Bar after anchoring, D. Simple bar. U answer. Answer B. Explanation. In case of heating, the bar gets elongated and shortens after heating, and after anchorages are applied on both sides which stretch the bar. Clamp splices are equipped with bolts and nuts since there will be a considerable reduction in the tensile strength of up to 50%. These type of splice can be used only in locations where the pre-stressing force can be sufficiently reduced by the curvature of tendon due to friction. 10. How many wedges are considered in the case of torpedo splices? A. 3. B. 4. C. 5. D. 2. U. Answer. Answer A. Explanation. Tendons are spliced in case of continuous pre-stressed concrete members to gain continuity, and the various types of splices used as tendons are screw connector, torpedo splices, clamp splice, and wrapped splice, and torpedo splices consists of triple wedges for securing the wires, and the entire unit is covered and protected by a sleeve, and this type of splice is largely used for splicing cold-drawn wires. Sand Foundry Global Education and Learning Series, Pre-Stressed Concrete Structures. Pre-stressed concrete structures questions and answers, chemical pre-stressing. Previous. Next. This set of pre-stressed concrete structures multiple choice questions and answers, MCQs, focuses on chemical pre-stressing. 1. The chemical pre-stressing is also called as underscore 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 underscore. A. Self-stressing. B. Whole stressing. C. Half stressing. D. Model stressing. U. Answer. Answer A. Explanation. Self-stressing or chemical pre-stressing of concrete was made possible by the development of expanding cements by Laussier of France in 1944, and generally expanding cement consists of 75% Portland cement, 15% alumina cement, and 10% gypsum, which results in formation of calcium sulfoaluminate. 2. The linear expansion of the cement in chemical pre-stressing is about underscore 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 underscore. A. 5 to 10%. B. 2 to 3%. C. 3 to 4%. D. 6 to 7%. U. Answer. Answer C. Explanation. The linear expansion of the cement in chemical pre-stressing is about 3 to 4%. Mikhailov has reported that expansive cements have been used for pre-stressing purposes in erstwhile in USSR since 1949, and splices are adopted for circular pre-stressing of tanks, and the advantage is that there is no reduction in the strength of wire. 3. The degree of expansion can be controlled by varying the conditions of underscore 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 underscore. A. Bending. B. Bonding. C. Heating. D. Curing. U. Answer. Answer D. Explanation. The degree of expansion can be controlled by varying the curing conditions in expanding cements, and when the concrete is subjected to compression, the amount and rate of expansion is controlled by controlling the curing conditions of the member. Advertisement. 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 Answer A. 4. The expansion of the concrete is 5. The tensile stresses developed in steel by the expansion of concrete are about underscore 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 underscore. A. 850N/mm2. B. 250N/mm2. C. 600N/mm2. D. 500N/mm2. U. Answer. Answer A. Explanation. Tensile stresses of up to 850N/mm2 were developed in steel by the expansion concrete results of laboratory investigations of several types of chemically pre-stressed elements, such as beams, slabs, frames, columns, pipes, and hyperbolic parabolic sheets have demonstrated the feasibility of chemical pre-stressing. 6. The chemical pre-stressing is generally suited for elements like underscore 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 underscore. A. Precast beams and columns. B. Bonding elements. C. Breakage elements. D. Tensioning elements. You answer. Answer A. Explanation. It has been found that structural elements ideally suited for chemical pre-stressing include pipes, thin walls and slabs, shells, folded plates and composite columns, as well as precast beams and columns. 7. The method of chemical pre-stressing is not suited for A. High degrees of prestress. B. High degrees of compression. C. High degrees of anchoring. D. High degrees of jacking. You answer. Answer A. Explanation. In the present state of art, chemical pre-stressing can be applied to structural elements and systems in which the optimum amount of pre-stress is relatively low, and this method is most not suited for high degrees of pre-stress and high percentages of steel where mechanical pre-stressing can be conveniently used. 8. The suitability of post-tensioning is good for A. Long spans. B. Break spans. C. Edge spans. D. End spans. You answer. Answer A. Explanation. The suitability of post-tensioning is good for medium to long span in situ work, where the cost of tensioning is very less, and the major advantage of is the stopped-off and curved cables are allowed by which designer can easily differ the pre-stress distribution. 9. The long span decks are fabricated by A. Post-tensioning. B. Pre-tensioning. C. Thermoelectric prestress. D. Chemical prestress. You answer. Answer A. Explanation. Post-tensioning is ideally suited in concrete construction work involving stage pre-stressing. Most of the long-span bridge structures are constructed using post-tensioning system, and long-span bridge decks are also fabricated by the use of post-tensioning. 10. The concrete dams are constructed using which? A. Post-tensioning. B. Thermoelectric pre-tensioning. C. Biological pre-tensioning. D. Elongation pre-tensioning. You answer. Answer A. Explanation. Concrete dams, biological shields of nuclear reactors and circular pre-stressing of large concrete tanks are strengthened by using post-tensioning, and high-tensile wire is wrapped under high tension using a wire-serving machine developed by the inventors. Sand Foundry Global Education and Learning Series, Pre-stressed concrete structures. Pre-stressed concrete structures questions and answers, basic assumptions. Previous. Next. This set of pre-stressed concrete structures multiple choice questions and answers, MCQs, focuses on basic assumptions. 1. The analysis of stresses developed in pre-stressed concrete structural elements is based on how many assumptions? A. 5. B. 4. C. 3. D. 2. You answer. Answer C. Explanation. The analysis of stresses developed in a pre-stressed concrete structural elements is based on the following assumptions. Concrete is a homogeneous elastic material. Within the range of working stresses, both concrete and steel behave elastically, notwithstanding the small amount of creep which occurs in both the materials under sustained loading. A plane section remains plane even after bending. 2. The tensile stresses when do not exceed the limit of modulus then change in loading of member results in A. Change of bending moment. B. Change of stress. C. Change in shear. D. Change in rupture. You answer. Answer B. Explanation. As long as tensile stresses do not exceed the limit of modulus of rupture of concrete, corresponding to the stage of visible cracking of concrete, any change in loading of the member results in a change of stress in the concrete only, the sole function of the pre-stressing tendon being to impart and maintain the pre-stress in the concrete. 3. Which conditions are negligible at the stage of visible cracking on concrete? A. Bending conditions. B. Joint conditions. C. Zone conditions. D. Loading conditions. U answer. Answer D. Explanation. Up to the stage of visible cracking on concrete, the changes in the stress of steel, the loading being negligibly small, are generally not considered in the computations. The phenomenon of stress corrosion in steel is particularly dangerous, as it results in sudden brittle fractures. Advertisement. 4. The stresses due to pre-stressing are referred as underscore 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 underscore. A. Combined stresses. B. Bending stresses. C. Anchoring stresses. D. Tensioning stresses. U answer. Answer A. Explanation. The stresses due to pre-stressing alone are generally combined stresses due to the action of direct load and bending resulting from an eccentricity applied load. The stresses in concrete are evaluated by using the well-known relationship for combined stresses. This type of attack in alloys is due to the internal metallurgical structure, which is influenced by composition, heat treatment, and mechanical processing. 5. Which of the following notations are used for evaluating the relationship for combined stresses? A. P. E. M. A. I. B. P. Sigma. M. G. I. C. P. W. M. Pi. L. D. P. Theta. M. Z. L. U answer. Answer A. Explanation. The notations and sign conservations used for the analysis of prestress are P. Prestressing force, E. Eccentricity of prestressing force, M. P times E. Moment. A cross-sectional area of the concrete member, I. Second moment of area of section about its centroid. 6. The uniform prestress in a concrete member subjected to concentric prestressing is underscore 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 underscore. A. P/E. B. P/S. C. P/T. D. P/A. U answer. Answer D. Explanation. Uniform prestress in concrete P/A, which is compressive across the depth of the beam, and the applied loads, dead loads of the beam include tensile stress towards the soffit, and are counterbalanced more effectively by eccentric tendons. 7. In case of eccentric prestressing force, the support force sup is underscore 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 underscore. A. Sup equals P/A, 1 plus IB/I2. B. Sup equals P/A, 1 plus IB/I2. C. Sup equals P/A. D. Sup equals P/AB. U answer. Answer B. Explanation. The stresses developed at the top and bottom fibers of the beam are obtained by the two relations. Finf equals P/A plus PE/ZB equals P/A, 1 plus IB/I2. Sup equals P/APE/ZB equals P/A, 1 YBT/I2. 8. The diagram indicating the direct stress of the beam is A, B, C, D. U answer. Answer A. Explanation. 9. The diagram indicating the bending stress of the cross-section the beam is A,